mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. And as promised, on today's video tutorial, we will be doing a summary video on sequences and series, right? We will also be going through some nice application questions that I got from the Platinum Mathematics Grade 12 learner book by Bradley M. Campbell J. and Meg Petrie S. The questions that we'll be going through together are amazing application questions that resemble common questions that are normally asked in your tests and in your exams. This video tutorial, guys, will be very detailed, and it is important that as I go through all the questions, you take down notes and you go through all the solutions with me. Please watch the whole video tutorial, and if you can't finish it today, please make sure that you allocate a day where you'll get enough time to finish the video tutorial. Okay, because this video tutorial, guys, is going to be very informative, right? Before we get started, guys, please make sure that you are subscribed to the channel. Please make sure that you click on the notification bell so that you get notified every time I upload a new video tutorial. And please make sure that you give this video tutorial a huge thumbs up. The plan is to get this tutorial to 1,000 likes, so please make sure you smash that like button because that also helps the channel grow and reach more learners that want to better their mathematics marks. Let's just take a quick look at what we'll be tackling or covering in today's video tutorial. So as the slides pass, please make sure that you take screenshots, especially where you see the questions pop up. Right, please make sure that you take screenshots of those slides, right? And once that is done, guys, we can get started with the video tutorial. Alright, so as you can see, guys, from the questions that I've extracted from the Platinum Mathematics Grade 12 learner book, right, I've actually taken out questions that cover the concepts that we will cover in the summary video today, guys, right? Alright, guys, so let's get started with the video tutorial. Alright, guys, so what is a sequence? Okay, a sequence is a list of numbers that are in a particular order, right? Let's have a look at an example. Okay, so if you're given a list of numbers like 2, 6, 10, and 14, right, we can say that this list of numbers is a sequence. Why can we say that this is a sequence, right? Because they're in a particular order. Why am I saying that they're in a particular order? Because to move from one term to the other term, we need to add what? We need to add 2. To move from term 1 to term 2, we add 4. To move from term 2 to term 3, we add 4. And to move from term 3 to term 4, we add 4, right? So we see that this is in fact a sequence, right? Because you've got this list of number that is in the order of adding 4 to get to your next term, right? So therefore, this is a sequence, right? So I'll repeat, a sequence is a list of numbers that are in a particular order. Now, what is a series? Okay. It's important that we understand that a sequence is not the same thing as a series, right? There's a difference between a sequence and a series, right? So what is a series? A series is what you get when you get the sum of the terms in a sequence, right? So what do I mean by this? If I give you the same list of numbers, right? 2, 6, 10, and 14, right? What would make this list of numbers a series? If you add the terms of the sequence together, then the sequence will then become a series, right? Why would it become a series? Because now we are getting the sum of the terms in this sequence, right? So let's just get the sum of these terms. 2 plus 6 plus 10 plus 14 is equal to 32. Okay, therefore the sum of the series is 32, right? So a sequence is a list of numbers that are in a particular order, and a series is what you get when you get the sum or when you add the terms of a sequence. Okay, guys? Guys, it's important to note that in your tests and in your exams, you'll be assessed on 3 types of sequences, right? Namely, the arithmetic sequence, the quadratic sequence, and the geometric sequence, right? And it is important that you know how to differentiate between these 3. If you want an in-depth explanation on how you differentiate between these 3 sequences, guys, please make sure that you watch this video tutorial, right? And I'll put a link to it in the description box. So now, just roughly, how do you know that you are given an arithmetic sequence, right? You will know that you are given an arithmetic sequence if you have a first common difference, right? How will you know if you are given a quadratic sequence? You'll know that you are given a quadratic sequence when you get a second common difference. And you'll know that you are working with a geometric sequence when the sequence does not have a first common difference, right? And the sequence does not have a second common difference, right, when you're evaluating it, but the sequence has a common ratio. Okay, so when you have a common ratio, right, that's when you'll know that you're actually evaluating a geometric sequence. It is also important to note that an arithmetic sequence can be defined in the following way, right? So if you're working with an arithmetic sequence, guys, you need to understand that, okay, if you're given A, which is the first term, A plus D is the second term, A plus 2D, third term, all the way to A plus N minus 1 times D, right? So an arithmetic sequence can be defined in the following way, right? Where your A is your T1, your A plus D is your T2, your A plus 2D is your T3, right? And your A plus N minus 1 times D is your Tn, right? So that is another way that an arithmetic sequence can be defined, okay? Making the equation that you use to get the general formula for the nth term to be equal to Tn, which is equal to A plus N minus 1 times D. Okay, so this is the formula that you use when you are required to get the general formula for the nth term of an arithmetic sequence. Let us have a look at the quadratic sequence, right? The equation that we use when we want to get the general formula for the nth term of the quadratic sequence is Tn, which is equal to an squared plus bn plus c. Okay, where the variables, right, a, b, and c can be obtained by using these 3 equations, right? So to get the value of a, right, in your quadratic sequence, you use 2a is equal to your second difference. Okay, you use 3a plus b is equal to T2 minus your T1. So it's your term 2 minus your term 1. And you use the A plus B plus C is equal to your term 1. Another important point, right, that you guys need to take note of here is that you need to ensure that these three equations are in exactly this order. So you need to first get 2A before you can use the 3A plus B, which is equal to T2 minus T1 equation, right? So you need to first solve this equation before you can solve that equation, right? So this equation needs to be solved first, then this equation, then that equation, right? So that is how you get the three variables A, B, and C for your quadratic sequence, right? And lastly, guys, when you are evaluating the geometric sequence, it is important to note that a geometric sequence can also be defined in this way, right? So a geometric sequence can be defined in this way. You can say that your A times R, A times R to the power of 2, A times R to the power of 3, going all the way to A times R to the power of n minus 1, right? Where your A is the first term, your A times your R is your second term, your A times your R squared is your third term, right? Your A times your R to the power of 3 is your fourth term, and your A times your R to the power of n minus 1 is your nth term, right? So a geometric sequence can also be defined in this way, right? Where the equation that we can use to get the general formula for the nth term of your geometric sequence is Tn, which is equal to A times R to the power of n minus 1. Okay, let us also just get clarity on what all these variables mean, right? For your arithmetic sequence, guys, your A is your first term or your T1, okay? And your D is your first difference, okay? Right? With your quadratic sequence, guys, your A, I've already explained that you get your A by saying your 2A is equal to your second difference, right? So we are able to get the value of A by saying 2A is equal to your second difference. We are able to get the value of B, right, by saying 3A plus B is equal to T2 minus T1. And we are able to get the value of C by saying A plus B plus C is equal to T1, right? So that is how you get the variables A, B, and C for your quadratic sequence, right? And for your geometric sequence, guys, right, the A is your first term, right? The A is the first term, so it's still the same thing. Your A is your T1, which is your first term, right? And your R is your common ratio. All right, guys, so we've basically covered all that you basically need to know when it comes to sequences, guys. You will be assessed on three kinds of sequences: the arithmetic sequence, the quadratic sequence, and the geometric sequence, right? You need to know that with an arithmetic sequence, for you to be able to say that a sequence is arithmetic, that sequence needs to have a first common difference. For you to say that a sequence is quadratic, that sequence needs to have a second common difference. And for you to say that a sequence is geometric, that sequence has to have a common ratio. I also explained that when you're working with an arithmetic sequence can also be defined as your A, right, which is the first term. The second term can be defined as A plus D, right? And that does make sense because what happens, right? For example, if you are given the sequence 2, 4, 6, 8, and 10, right? For us to move from one term to the other, what do? We add 2 here, right? To go from 2 to 4, we need to add 2. To move from 4 to 6, we add 2, right? To move from 6 to 8, we add 2, right? Meaning that the first common difference, right, the D for this sequence is 2, right? And the A for this sequence is the first term, which is 2, okay? So to explain this part here, where I said that arithmetic sequence can be defined as A plus D, A plus 2D, right? I'm explaining that concept there, right? And showing you what I mean by that concept, right? Okay, I said that the arithmetic sequence can be defined by A. So what is your A in this case here? The A is 2, right? And then the second value, how did they get the second value? I said that they get the second value by saying A plus D, right? So A plus D, so it's going to be 2 plus 2, which is 4. And that is correct because they got the 4 there. How did they get the third value? I said it's going to be the A, and the A is 2 plus 2 times D, which is 2, right? And that should give us what? 6. So it's 2. So 2 times 2 is 4 plus 2 is 6, which is that value there, right? So that is what I mean by saying that an arithmetic sequence can also be defined in this way, right? That is how they got the equation that we use to get the formula for the nth term to be Tn, which is equal to A plus n minus 1 times D, right? So that is what I mean by that, okay? And then I've explained how you get the variables A, B, and C for your quadratic sequence, right? And I also further explained that with a geometric sequence, right? A geometric sequence can be further defined as your A, right? And A times R and A times R squared, meaning that if you're given a typical geometric sequence, right? Let's say they give you the geometric sequence 3, 6, 12, and 24, right? First thing we need to do for us to check that it is in fact a geometric sequence, we need to ensure that we've got a common ratio, right? So how do we get your common ratio? To get your common ratio, we take your term 2 divided by term 1, and that should be equal to your term 3 divided by your term 2, and that should be equal to your term 4 divided by your term 3, right? So if we take your term 2, right, so this is term 1, this is term 2, this is term 3, and this is term 4. If you take your term 2, which is your 6, and you divide it by your 3, what do you get? You get 2, right? So this sequence has a common ratio 2. You can also check with, if you take your term 3, which is 12, and you divide it by 6, you will still get 2, right? So this sequence has a common ratio that is 2, right? So what do I mean by when I say that as a geometric sequence can be defined as A times R squared. What do I mean by that, right? If your A is equal to 3, because that is your A is the first term. So if your A is equal to 3 and your R is equal to 2, like we calculated, right? Let's just double check what I'm saying there, if it makes sense, right? We said that the first term is your A, right? And we see that the first term is in fact your A, which is 3, right? We said that the second term is the A times by R, right? So what is your A? Your A is 3. And what is your R? Your R is 2. And 3 times 2 is 6, right? Let's check A times R squared, right? What is your A is 3. What is your R is 2 squared, right? So if you take 3 times 2 squared, what do you get? You get 12, right? So that is what I mean when I say that your geometric sequence can be defined by A times R squared, right? Meaning that the equation that we use to get the general formula of the nth term is Tn, which is equal to A times R to the power of n minus 1. Okay, guys, I hope everything made sense here. Let us move on. Now, guys, let's have a look at series, okay? When it comes to series, guys, you will be assessed on an arithmetic series as well as a geometric series, okay? When we are evaluating an arithmetic series, the formula that we use to get the sum, because I mentioned that a series is the sum of the terms in a sequence, right? So when we're evaluating an arithmetic series, the formula that we use to get the sum of an arithmetic series is Sn, which is equal to n over 2a plus n minus 1 times d, right? So that is the formula, guys, that you use if you are asked to get the sum of an arithmetic series, okay? And like I mentioned, guys, in the previous slides, the a is the first term, right? The d is the first difference, right? And the n is the position of the term in a sequence. Okay. And when you're given a geometric series and you're required to get the sum of that geometric series, guys, there are two equations that you guys can use to get the sum of that geometric series, right? Okay, so what are those equations that you guys use, all right? So I'm going to split this geometric series part into two, okay? Right? So the first one. So what determines the equation that you're supposed to use to get the sum of a geometric series, right? What determines that, right? It is the value of your common ratio, okay? So if your value of your common ratio, if your R is greater than 1, right, then the equation that you use to get the sum of the geometric series is Sn is equal to a times r to the power of n minus 1 all over r minus 1. So this is the equation that you use when you get a common ratio that is greater than 1. You use the equation Sn, which is equal to a, open brackets, r to the power of n minus 1 all over r minus 1. So that is the equation that you use. However, if you get a value of r, or if your common ratio is less than 1, then the equation that you use to get the sum of the geometric series is a times 1 minus r to the power of n all over 1 minus r. Okay, so these equations are given to you guys in your formula sheet, but I mean the formula sheet is useless if you do not understand when you are supposed to use that equation. So it's important that you guys remember, if r is greater than 1, a way to remember this is that if your r is greater than 1, then you need to use the equation that starts with the r to the power of n minus 1, right? And if your r is less than 1, you need to start with 1 minus r to the power of n. Okay, so those are the two equations that you use if you have to calculate the sum of a geometric series, right? But we are not done, guys. Also, when you're working with the geometric series, right, you also do get infinite geometric series, okay? So what is an infinite geometric series, guys? An infinite geometric series is a geometric series that goes on until infinity, right? So it has no end. It is a geometric series that has no end, right? And with these infinite geometric series, right, you get two types of them, right? You get a divergent infinite geometric series, and you also get a convergent infinite geometric series, right? So what is the difference between the two, right? With a divergent infinite series, right, the terms of the series are all positive numbers. And when you get the sum of all these values, you will notice that the sum will get bigger and bigger and bigger without any end, right? And when this happens, we can say that this infinite geometric series is divergent, right? So an example of this would be, all right, so let's say they give you an infinite geometric series, right, that is of this form, right? So I'm going to give you this infinite geometric series in sigma notation, but we are still going to go into depth and explain what sigma notation is, right? So let's say they give us this infinite geometric series that starts at k, which is equal to 1, going all the way to k, which is equal to infinity, right? And the formula to get Tn for this infinite geometric series is given as 2 times 3 to the power of k minus 1, right? So I'm going to explain what I mean when I say that the sum of these terms will get bigger and bigger and bigger without any end, right? So now if you were to get term 1 of this infinite geometric series, how would you get it, right? You would say 2 times 3 to the power of, where you see k, you're going to put a 1 minus 1. You're going to get your answer. Okay, let's get term 2 of this infinite geometric series. You're going to say 2 times 3 to the power of 2 minus 1, and you're going to get our answer. Let's get term 3 of this infinite geometric series. It's going to be 2 times 3 to the power of 3 minus 1, and we're going to get the answer. And let's get term 4 of this infinite geometric series, right? And term 4 of this infinite geometric series is obtained by saying T4 is equal to 2 to the power of 3, right? 4 minus 1, right? So let's just put all these values into our calculator and write down these terms, right? So term 1 is going to be 2. Term 2 is going to be 6. Term 3 is going to be 18. And term 4 is going to be 54, right? And it is important to note that we will go on and on and on and on. So we're not actually going to stop, right? We're going to go all the way until t infinity, right? But I mean, that's not practical, so we're not going to do that, right? And what I said that is that with a divergent infinite series, the terms of the series, right? So the terms of this series are all positive numbers, right? So we can see that here, all the terms of this series, right, are positive numbers. And when you get the sum of all these values, or the sum of all these terms, you will notice that the sum will get bigger and bigger and bigger without any end. So it will get bigger and bigger and bigger without any end, right? So the sum of these terms, right, is going to be 2 plus 6 plus 18 plus 54 plus, and the sum will get bigger and bigger and bigger, right, without any end, right? So that when we see that this is happening, then we will know that we are dealing with a divergent infinite geometric series, right? What about a convergent infinite series? What is a convergent infinite series? A series, right, or an infinite geometric series is convergent when you find that the common ratio that you obtain is between -1 and 1, right? So you are given an infinite geometric series, right? So you're given an infinite geometric series, right? And you find that the value for r that you'll be given for that infinite geometric series will be between -1 and 1, right? And it is also not equal to 0. And when you see that that infinite geometric series that you're given has a value of r that is between -1 and 1 and not equal to 0, then we can confirm that this series is a convergent infinite geometric series. And when you have a convergent infinite geometric series, when we want to get the sum of this convergent infinite geometric series, you use the equation. You can use the formula sum of infinity is equal to a over 1 minus r, where your r is the first term, right? Or your T1, right? And we already know that your r is your common ratio. So if you have confirmed that your common ratio, right, for an infinite geometric series is between -1 and 1, then we can use the formula sum of infinity is equal to a over 1 minus r. Okay, and this will give you the sum of that convergent infinite geometric series. And it is also important to note that if you are given a convergent infinite geometric series, right, the values that you will get when you sum up the values or when you sum up the terms of that series, right, or of that sequence, you'll find that the values will approach or converge or get closer to a particular value, right? So they're not going to get bigger and bigger and bigger like what we got when we were working with the divergent infinite geometric series. But in this case, these values, if you sum them up or if you sum up these terms, right, they will start to move closer and closer to a particular value. Okay, so with a divergent infinite series, right, the sum gets bigger and bigger. Okay, and with a convergent infinite series, right, the sum approaches a particular value. All right, so these are the differences between a divergent infinite geometric series and a convergent infinite series. And the last concept that I would like to explain is the concept of sigma notation, right? And sigma notation, guys, is an important concept in the series, right? Because you will get questions in your tests and in your exams where you are given an arithmetic series in sigma notation, or even a geometric series in sigma notation, like what I did in the previous slide with you guys, right? So that's a geometric series in sigma notation, right? So you need to be able to evaluate such questions. So what is sigma notation, right? Sigma notation, guys, is just another way of representing the sum of a series. So the symbol, right? This is the symbol, and it is called sigma, means sum. All right? So let us just have a look at an example. All right, so let us have a look at this example. This example is asking us to evaluate the sum of this series from n, which is equal to 4, to n, which is equal to 70, right? Okay, so when you're working with sigma notation, guys, it is important to remember that it's important that you guys remember these steps, right? When you're given a series in sigma notation, the first thing you need to do most of the times, right, is that you need to obviously get the first 4 terms of the series, right? So number 1, okay. Number 2, you need to confirm what type of a series that you're working with. Then lastly, right, depending on whether it is an arithmetic series or a geometric series, right, then you will be able to determine which formula you can use for the sum of that series, right? So depending on the type of series, you'll be able to use the appropriate formula to get the sum, right? So these are the important steps that you need to remember when you're working with sigma notation. Get the first 4 terms of the series, right? Confirm the type of series you are working with, right? And depending on the kind of series, you'll be able to use the appropriate formula to get the sum. Okay, so now let us basically deal with this particular example. We are asked to evaluate the sum of this series from n, which is equal to 4, to n, which is equal to 70, right? So let's follow these steps that I've written down here for you guys, and let's solve this equation. Okay, so the first thing you do, guys, we want to get the first 4 terms, right? So T1 is going to be equal to, okay, we're going to take this equation as is, right? And we're going to substitute the first value, which is n, which is equal to 4, right? So we're going to say 2n minus 4, right? And we're going to substitute the 4. So it's going to be 2, 4 minus 4. That's your T1. Get your T2. T2 is going to be 2. It's going to be the next term after 4. What is the next term that comes after 4? It's 5 minus 4. And I get the third term. So it's going to be 2. What's the next term after 5? It's 6 minus 4. And we're going to get the last term, which is T4, which is 2. The next term after 6 is 7 minus 4. And I punch all these values into our calculator and get what the term 1, term 2, term 3, and term 4 are. Term 1 is 4. Term 2 is 6. Term 3 is 8. And term 4 is 10, right? So these are the 4 terms of the sequence, of the series. So guys, once we found the first 4 terms of the series, right, we can determine the type of, we can confirm, we need to check to see what kind of a series we are working with, right? So we've got, so I'm going to write that here, okay? We said the first term is 4. The second term is 6. Third is 8. And the fourth is 10. And it goes on and on like that, right? So we need to confirm if it's an arithmetic series or if it's a geometric series, right? So here we can already see that this is actually an arithmetic series. Why am I saying that it's an arithmetic series? Because we can see that we have a first common difference of 2, right? So 6 minus 4 is 2. 8 minus 6 is 2. And 10 minus 8 is 2, right? So we've got an arithmetic series. And because we've got an arithmetic series, what does that tell us? It tells us to get the sum of this arithmetic series. We use the formula Sn, which is equal to n over 2a plus n minus 1 times d, right? Okay, so let us just determine all the values. What is a? We know that a is the first term. So what is the first term for this arithmetic series? The first term is 4, right? Okay, what is d? The d is the first common difference, right? And the first common difference is 2. And what is n, right? What is n? We are told that the sum of, okay, we are told that we need to get the sum of this series, right, from n, which is equal to 4, to n, which is equal to 70, right? So how many terms are in this series, right? So this is a very important point that you guys need to be aware of. To get the number of terms that are in the sequence, or in the series actually, to get the number of terms that are in the series, right, this is the equation that you need to use, right? So I'm just going to rewrite this question here. We're given sigma notation, n, which is equal to 4, 17. Okay, so to get the number of terms that are in this series, right, we use the formula, the top number, right? So it's going to be the top number minus the bottom number plus 1, right? So it's the top number, which is 70, top number, which is 70, minus the bottom number, which is 4, plus 1, right? So let us do that. So the top number is 70, minus the bottom number, which is 4, plus 1 is going to give us the number of terms that are in this sequence, the series, right? So 70 minus 4 plus 1 is equal to 67 terms, right? So now we know that we've got 67 terms, right? And that is going to be our n value. So now, once we've calculated the value of our n, we can now calculate the sum of our arithmetic series. So the sum of our arithmetic series is equal to, okay, so the sum of this arithmetic series from n, which is equal to 4 to n, which is equal to 70, right, is 4,690, right? So this is where I'm going to stop this video tutorial, guys, because it's getting a bit too long, right? Please make sure that you watch the part 2 video tutorial, because in the part 2 video tutorial, we are going to be going through these revision test topics, right, that I got from the grade 12, the Platinum Mathematics grade 12 learner book, right? So please make sure that you hit that notification bell so that you do get notified when I upload this video tutorial, guys. And also please make sure that you are subscribed to the channel, and also please make sure that you have given this video tutorial a huge thumbs up. Also, please do make sure that you watch this part 2 video tutorial, because it will cover all the topics that I've covered in the summary video tutorial, right? And helping you guys understand how you apply all those concepts. So please make sure that you do watch this video tutorial, because it will also be very informative. And this part 2 video tutorial will cover the application part of this summary video tutorial. And that is it, guys. And I'll see you guys on my next upload. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.